Let us do one more problem, but directly let us do this problem with the computer methods. Okay. So, the problem is like this. So, their members are arranged in this manner. These are my supports and these are my loads. Okay. The dimensions are given. This is 3 meter, 3 meter, this is also 3 meter. Okay. Let us mark the nodes A, B, C, D, E, F. Okay. So, this has area A, this has area A, this has 0.8A, 0.8A, 0.8A and 0.8A, and these two members has 1.2A, okay, where A is 5000 mm square and E is constant. Okay. Let us mark the unrestrained degrees of freedom for this problem. So, this is delta 1, delta 2, delta 3 and delta 4, 5, 6, 7 and 8. Let us also mark the restraint degrees 9, 10, 11 and 12. So, the reference axis system is this way, this is x y, and each member will have a local axis. To do that, we have to identify the j and k ends of each member. Let us do that here. So, let us say member j and k ends of each member, okay, length of the member in meters. Let us enter theta. Let us find Cx and Cy, then enter the global labels, because these are the input for my computer program. So, members AB, okay, BC, CD, DE, AF, FE, BF, CF and DF. There are 9 members, 1, 2, 3, 4, 5, 6, 7, 8, 9 members. Okay. For the member AB, I am taking this as A and B. So, similarly, this becomes a local axis. So, this becomes my xm, this becomes my ym. Similarly, I can mark for all the members, I am entering the values. The length of the member is 3 meters, theta is anticlockwise degree 90. So, I can enter Cx and Cy. For member BC, similarly B and C 3 meters 0, 1, 0. For the member CD, C and D ends are J and K ends 3 meters, CD is this member 0, 1, 0. For DE, this is E and D. So, I should say that this is my xm and this is my ym for the member DE. Okay. So, this is 3 meters plus 90 degree, okay, because this angle is 90 degree. So, it becomes 0 and 1. So, AF is this member, the horizontal member, which has got A and F as J and K ends, length is 3 meters, 0 degrees. So, 1 and 0. FE is this member, where F and E or J and K ends, length is 3 meters, 0 degree, 1 and 0. BF is this member, I say B and F. It means this is my XM and this becomes my YM. So, you know XM is inclined minus theta by 45 degrees. So, let us enter that as minus 45 and this becomes 0.707 minus 0.707 and length of this member is root 2 times of 3, which is 4.242. CF is a vertical member. So, I should say F and C. It means the member is oriented this manner. This is my XM and YM for this member. The member has the length of 3 meters, the angle is plus 90, that is 0 and 1. So, DF is the last member which is got at D and F. So, the inclination is this way, this is my XM and this becomes my YM. Remember, from XM it is anticlockwise. Okay. So, XM measured from this angle will be 135. So, I should say the length is 4.242, okay. It is minus 135 degrees. Therefore, this becomes 0.707 and this becomes 0.707. Let us enter the global labels, y axis labels first, x axis labels next. Let us take the member AB, reference axis. So, very simple, 10 to 9 and 1. So, 10 to 9 and 1. Similarly, for this member 2, 4, 1 and 3. For the next member 4, 6, 3 and 5. For the next member 12, 6, 11 and 5. For the next member 10, 8, 9 and 7. For the next member 8, 12, 7 and 11. For the next member 2, 8, 1 and 7. For the next member 8, 4, 7 and 3. For the next member 6, 8, 5 and 7. Having done this, let us try to find out the transformation coefficients, that is the stiffness coefficients. The stiffness coefficients for the member AB, BC and so on is nothing but AE by L. I can find out the value and get the local stiffness matrix. Let us look at the program. There are 9 members. I have entered the length, you can see here 6 times 3, which is taken from here 1, 2, 3, 4, 5, 6, 6 times 3, correct. Then 4.242, 3, 4.242, you can see here 4.242, 3, 4.242. So, I am following exactly the same method by entering the data. Length is entered, area is given, okay. Then theta 90 00 90, you can see here 90 00 90, then 00 minus 45, okay. 00 minus 45 is 90 minus 135. So, we entered, we found out the global labels. For example, member 1 10 to 9 1, you can see here member 1 has 10 to 9 1, is it not? So, we have the value. Once I do this, we have got the transformation matrix for each the member, then we compute the transformation matrix, local stiffness matrix for each member, okay, which we get here. Then we assemble them, get global stiffness matrix, then stiffness matrix complete is plotted. From that KUU is obtained, K bar UU is obtained, then inverse is obtained. Okay. So, now I have K bar UU, I also have K bar UU inverse, okay, from this. Now, let us come to the joint load vector. So, look at this figure, the degrees of freedom, look at the problem. So, at 1 it is plus 20, okay. Then 2 and 3 no load, at 4 it is minus 70, remaining all are 0. Okay. So, typically plus 20, 0, 0, minus 70 and all zeros, let us see that here, plus 20, 0, 0, minus 70, then all are zeros, is it not? So, I created the joint load vector, then I applied the problem, found out unrestrained displacements, then found member forces in all the members and got the solution for this problem, which I am going to discuss it here. The answer is given in this sheet for all the members. Okay. The unrestrained stiffness matrix available here, the inverse is available here, then the del bar u is available here, okay, whereas the E multiplier is common available. Joint forces are then plotted for this problem, which I am going to mark here. The end joint forces are marked here. This is the truss system I have. Okay. The degrees of freedom, this is going to be, you can check once again, the degrees of freedom are 1, 2, 3, 4 and so on. So, let us mark them here accordingly. So, I should mark this as plus 20, okay. Then 0, 2, 3 0, this is minus 70, 4, 5 is 0, remaining all are 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So, let us mark this as minus 10, okay, and this value as plus 25, then this as again minus 10 and this as plus 45. Let us check. This is point A. So, let us take moment about the point A, 20 into 3 plus 70 into 3 minus 45 into 6 is 0. So, it is checked. Okay. The reaction is being met, the total load is being met. So, I can also draw the member forces for all the members. Let us say member 1, member 2, member 3, member 4, member 5, member 6, 7, 8 and 9. Let us mark the member values as well. So, this is 25 and 25, this is 45 and 45, this is again 45 and 45, this is 10 and 10, this is okay, this is 10, this is also 10 and 10, okay, this is again 45 and 45. So, this is 45, 45, 45 and 45. For this member, this is 25, 25, 25 and 25. For this member, it is 70 and 70. Okay, the member reactions are found and they are as same as what you have here, which is going to be, so this value is 10 and this value is 25 and this value is 45 and this value is again 10, okay, which is as same as what you have here. So, friends, we now write down the summary. We solved 2 example problems on planar truss system. We have used the computer codes to solve the problem. Codes are explained to prepare the input data for the program. The results are then interpreted. I hope you have understood. You will practice this computer program in your MATLAB software and try to solve couple of more problems and understand. They are very interesting and simple. I wish that you should exercise all these problems back again at your desktop and try to compare the answers, and you will share your views and conveniences you get by adopting this computer method of structural analysis using stiffness methods for solving a variety of problems. Thank you very much.